Alright, we're going to talk in this video about geometric probability. So hopefully you'll remember some basics of probability that'll help for this lesson. Okay, so start with the warm-up. You can stop the video, try the warm-up. You're supposed to find the area in the perimeter of the shaded region. I'm going to go ahead and put the answers up on the board. Okay, let's talk about the next one. The next one is all about probability. So let's look at this. All right, if there are 3 red, 2 blue, and 4 green marbles in a bag, what is the probability that you will pick a red marble? And so pretty instinctively, I'm hoping a lot of you will say, okay, well, there's 3 red marbles, and out of the entire group in this bag, there are going to be 9 marbles. 3 red, 2 blue, 4 green. So 3 out of 9 would be your probability to pick a red marble, or you could think of that as 1/3. Okay, so probability, just to give you a bigger picture in general, is always the number of possibilities or possible outcomes divided by the total number of outcomes. So something smaller is always in the numerator, and that's being divided by something larger and something that's total in nature. Okay, so the next one says, what's the probability that you will not pick a red marble? If you do not pick a red marble, that means you either pick the blue or the green. So let's think about how many options we have to pick blue or green. Well, there's 2 blue, 4 green, so that's 6 options that you will pick a marble that's not red out of the entire 9, which is really 2/3. All right, now this next one is, well, let me give you the vocab first. You can stop the video and jot this down if you want. It's pretty self-explanatory about probability, and we're going to do examples based on this vocabulary next. So you can stop. Okay, so here, let's do our first example. We're going to find the probability that a point chosen at random on RS lies on TU. So there's TU right there. So let's just say randomly something falls on the number line, and it can just randomly fall anywhere. There are 2 units in which it could fall on the line TU. So there are 2 possibilities, and we want to figure out how many total possibilities there are, and there are 10 total units, which that turns out to be 1/5. And then typically for this class and for this section, we're going to rate our probability as a percentage rounded to the nearest 10th. So this would be 20% if you wrote that as a decimal and then as a percentage. All right, let's look at a couple of these. Now these are pretty typical geometric probability problems. So find the probability that an object dropped at random will land on the shaded region. So here's your shaded region for the first one. And then this little sentence is not included in your notes, but it is important what I'm underlining right now. So the object that's going to land or be dropped and hit these shapes is equally likely to hit anywhere on the shape. So that's important. Okay, so this first one, part A, just kind of think about this one. You don't have to do a lot of math. How much of the circle is shaded? You can see that 1/2 of the circle is shaded. So there is a 50% chance of your object, which is going to randomly fall in the circle, is going to land in the shaded region. Okay, for part B we have to do a couple calculations though. So we want to find the probability that it's going to land, and again this object is going to just fall randomly on this circle. We want to know what's the chances it's going to land in this shaded region. So first what we need to do is find the area of the shaded region. And so we would do that by looking at this. The area of the shaded region is the area of the circle minus the area of the square. Okay, so the area of the shaded is the area of the circle, which is going to be 25 pi minus the area of the square, which is 50. It's 50 because you can see that this here is 5 and 5. And so you can think about this right triangle and how there are 4 of these right triangles inside the square. And so one of these triangles is 1/2 base times height, which is 25 over 2, and then we're going to multiply that by 4, which is 50. Okay, so if that's the area of the shaded region, right here, this 25 pi minus 50, we need to divide that area by the total possibility, or the total space for your object to land on the shape, which is the whole entire circle. The object can land anywhere on the circle, so we need to divide that by 25 pi, which is approximately 0.363 or 36.3%. Okay, one more. Find the probability that an object dropped at random will land in the shaded region. So first let's find the area of the shaded region, and that's going to be found by looking at this. Area of the circle minus the area of the triangle. Alright, so the area of the circle, the radius is 8. So the area of the circle is going to be 8 squared pi, which is 64 pi. And the area of the triangle is 1/2 base times height, which both the base and the height are 8, so 1/2 8 times 8. Okay, so the area of the shaded region is 64 pi minus 32. So that's your total possibilities for your object to land at, but you need to find the probability, which is the area of the shaded region divided by the area of the whole object, which is just the circle, which is 64 pi. When you divide, you get approximately 0.841, which is 84.1%. All right. We will practice tomorrow.